We're going to do number 4 here. You can see the definition of the function. The key words for the definition of the function would be, it's a rule in which for each input there's exactly one output. So those would be the key words to make sure you include when you are defining function on the test. So for number 4, using transformations. So this is the key, using transformations, not using factoring and finding x-intercepts and things like that. It's really using transformations. We're supposed to recognize here the parent function to this function would be y equals 1 over x squared. 1 over x squared, you're supposed to know, looks like this. And if you think about it here, when we have a factor of x in the denominator, that means that x equals 0 would be a vertical asymptote. Notice that the vertical asymptote here, the behavior on either side of the vertical asymptote, the graph goes up to positive infinity on either side, which is consistent with what we have talked about. If the multiplicity of that factor in the denominator that corresponds to the vertical asymptote is an even number, then on either side of that vertical asymptote, we're going to have the graph go in the same direction. So anyway, this is a basically, like I said, it's a parent function you're supposed to know the graph of. And we also would notice here the denominator has a greater degree than the numerator. We call that a proper rational function. And when we have that, we know that the line y equals 0 is a horizontal asymptote. Also, likewise, we already talked about the vertical asymptote. So if this is the parent function and we look at this function here, we see that we have a value that's being subtracted from the x. We always call that h. And so h is equal to 3. So we say therefore h is equal to 3. And then the number that's being added to the outside, that's our k. Well, with rational functions, the h, x equals the h is always going to be our vertical asymptote. So notice that in this case here, let me get my other red pen. So in this case here, we have h is equal to 0 and k is equal to 0. So we would say, therefore, if h is 0, then x equals 0 is a vertical asymptote. And then if k is equal to 0, that means that y equals 0 is a horizontal asymptote. So if you really want to make the connection between this function here and the parent function, then you really need to recognize what the values of h and k do to the graph of the function. So the h is always the vertical asymptote and the k is the horizontal asymptote. So if h is 3, that would be consistent with what we just said. H is 3, meaning that we move the graph, this function, over to the right 3 units. And that x equals 3 then is our vertical asymptote. Now again, if k is 2, that means that we're going to be moving this graph here up 2 units. And if we move the graph up 2 units, we have to also move the horizontal asymptote up 2 units. And after doing that, we now just draw the graph because we have the lane lines. We know the shape of the graph, and the shape of the graph is like that. And that is how you graph that function.